Piotr Kowalski. I make sculpture. I live in Paris and now I work at Del Toro, 9,000 miles from France, at North American Explosion Forming Factory, 50 miles south of Los Angeles. We are working in a team on a big piece of sculpture at this moment. The future is here. I mean, the future is not something tomorrow. The future must always start today. Otherwise, we don't have any future at all. And that's how I feel about North America and about working with Joe Corral, that we were working really in the future.
Pete was trying to express his feelings and express them in a free manner, so he was free-forming these things. What we're doing on a die is producing a product that has a requirement for a high degree of accuracy and repeatability to assure accurate fit on aerospace projects.
To me, the shattered pieces are destroyed. They are not pieces. They are beyond the point of control. They don't exist to me as form. The pipe was too small in diameter, and we just couldn't predict what would happen. And also, certain things happened that we couldn't even explain. We had too little experience. Some pipes, instead of expanding, collapsed, as if a vacuum was formed inside. Quite a few of them got squeezed where there was no explosive at all. If you have something to say, you want to say it as precisely as you can. At the end, where we knew exactly what we were doing and we were obtaining the shapes we wanted. First, I wanted to make a whole family of forms. All those pipes would be done the same way, just with variations. One would have a little more charge, one a little less, but they would still be all related to each other. And then I chose stainless steel, and I wanted it very shiny, because I felt that a very polished metal would express the energy that went into stretching it. You would really feel the skin of the metal being pushed out. Step by step, we tried continuous inside charge to expand the whole pipe, like a primer cord, suspended in the center, and exploded, then it would get a pressure all along the pipe. We tried a little ball charges to expand just the part of the pipe, and then we went into constricting, and I had a feeling that we would have to do two things at the same time. It means that we would have to expand and constrict in order to balance the forces. So playing with those factors, you can control the form, you can obtain what you want. What I would like to accomplish is to show in what way I got involved with explosion forming and how very closely it relates to my past work. What's curious is that those forms resemble the pipes made at Del Toro. All my previous works for the last 8 years is based on the use of materials and tension. I build out the elastic forms in which the concrete is put under pressure, and I work while the concrete is in liquid state. Now those are some columns out of plastic and plaster, and in this the liquid was in compression, pushing out the walls of the molds, which were restrained in some places. Here is an enclosure for a power station, and it's located in the Paris area in France. It's made out of translucent polyester, which lights up at night, and it's made out of between 1/8 and 1/4 inch thin wall, which was molded on tension surfaces. This is a part of architecture and made out of plastic. When you use plastic in a flat area, it doesn't have any rigidity to it. But by building in deformations and ridges, you introduce a great strength into a thin material. So the reason for ridges here was, one was technical, structural, that means introduce rigidity into a thin material. And the second one was aesthetic one, play with those ridges in such a way that it would look good. This is a project for an outdoor museum. It's going to house a sculpture in Italy. The walls are prefabricated out of metal, and the roof is out of translucent plastic. This is a metal fountain, about 3-story high. There are 2 hollow shapes, and in between you have water sprays that fill the internal space with water and noise. The water bouncing on the hollow shapes will produce sort of music. This is a floating island out of metal. Dimension be about 60 by 60 feet, 12 feet high. It should be done of aircraft metal, probably aluminum alloys. Again, this size piece could be very easily done with explosion forming. This is a fountain made of copper. There are 10 pieces. They are hollow inside. The water is fed from down below and builds up a pressure inside those forms, and the water comes out through the holes. You will probably be interested that those forms were not cast, and they were electrolytically formed. If you can imagine an air bubble in the water on which I could deposit metal, this was done more or less the same way. I was building a hollow space over which I deposited the metal, and once the first coat is thick enough to live by itself, then the process goes on, builds up and builds up more and more. This is plastic, interlocking, very complex topology. The last few pieces, the round ones, are dismountable. You can take them apart. This is plaster. This one plays on the hollow shapes and full shapes fitting into each other. This is some of the work of this year, 1965, with Susan and the Elders. This one is bright red, made out of plastic. This is the last piece I did before coming to the symposium. This is again out of plastic and metal. It's about 16 feet long by 10 feet wide by 8 feet high, with those big searchlights in it. You have this terror machine on one side with light in it, and you have human figures on the other. Confrontation between the terror and the man. This is a very large piece. It's a concrete wall which was poured in situ. It's in France, about 20 miles south of Paris, and it's in the civic center of a satellite town. It was commissioned by the French government. This wall, which divides the civic center into 2, is about 250 feet long and about 16 feet high. And it was done by sections 25 feet long, poured vertically, building up pressure inside those elastic molds. I want to add to it that this whole system is my own invention and patent. You will notice that this surface here is very close to the ridges I obtained with explosive forming on the sheets of stainless steel that we're going to be using for the sculpture. The metal was formed really beautifully, absolutely precise, and on that last piece we found the right sort of charge to use. We used the 400 grain cord on it, the same cord that we used to form the big parts. We found almost everything out of this piece. When it was finished, it convinced us that we could form the big sheets of metal without being too much preoccupied. You know, we knew where we were going, really. Now, when I start with the second project, I started with flat sheet of metal, and putting it into the die and giving it this orange peel, part of a spheroid shape, was getting the metal into the stage the pipes were before I started working on them. I just wanted the standard form of a certain resistance to work with.
One of the most fantastic advantages of this process is the ability to program your charges in local areas. You notice how that charge is beefed up on the edges?
Yes.
And thin in the middle? Well, that gives you the ability to put the energy where you want it to get the shape you want.
Do you feel, Joe, that we are on the way to speak the same sort of a language?
Definitely, because metalworking has always been a combination of science and art. The method of producing metal shapes successfully depends entirely on what sort of team you have between your scientific people and your people that have certain skills. And no one person has all those things. You've got to have a team, and you've got to have all the ingredients to come up with a successful project of this type.
And I do not feel like many artists do today that if you get involved into such process, you lose personality. I think on the contrary, that you can express yourself very well and very precisely working with the team. This is our team of sculptors. Ed Merfield, graduate student, Santa Barbara in San Diego. Janet Austin, graduate student, Otis Art Institute, LA County. Bill Artis, professor of art, Nebraska. Jim Hayworth, a sculptor in San Diego, student. And John Ventimiglia, a sculptor from New York. After the design was made on the sheet, put the tapes on to protect the metal from pitting, because the charges were applied directly to the surface of the metal. We used exclusively 400 grain per foot primer coat on them in different lengths, but exclusively this sort of explosive, no other one. The beauty of working with this explosion forming is that it should feel almost effortless. You know, you put those charges on, it's like drawing. You shouldn't feel any work behind it. You just work with energy, you know. You put those charges on, they explode, they disappear. All there's left is the form, the shape. So that's why I wanted the weight of the metal to disappear. Just feel the form. I think when the explosive pushes in the metal, the thing happens so fast that it doesn't propagate itself all over the sheet of metal. And I have a feeling that the metal becomes elastic. At the moment of explosion, it becomes really like a piece of rubber.
Real fast, and then it stops.
I think, yes, very fast, it becomes elastic, and then it stops.
And it's only in local areas where the explosive hits it.
I think so. Janet here is keeping our logbook. It is very important. It's as much part of the sculpture as a finished piece. We write every day all the steps we do, what charges we put on, and what are the results, and what steps we took. We would lay all the charges according to the drawing. We applied it on two pieces from the inside only, and on one piece from both sides, outside and inside. And we would shoot it once, and we would get a certain deformation of the sheets, which was not the final one. We wanted a deeper one. We wanted more deformation of the metal, so in all the cases we repeated the charges, the same charges, at least twice, and some places even 3 or 4 times, to deform more and more. Each time the metal moved between 1 and 1.5 inch. I was invited in the winter of 64-65 to come to the Long Beach State College for the symposium. From Paris, I wrote Long Beach College that I would like to work with explosion forming. And that was the main reason why I came to the symposium. I had a feeling that in one way or the other I could do it here. I am sure that sculpture on a very large scale is architecture. I can see myself and other sculptors not only designing facades of the building, but doing the whole building. I think with this method, with the explosion forming, you can imagine fantastic things. Can you think of a roof of an auditorium or a theater being made out of one piece of stainless steel, hundreds of feet long, in which we put stiffness,